Hello everyone. In this video, we are going to solve a system of two equations which have three variables. That is x plus y plus z equal to 3. This is one equation. X cube plus y cube plus z cube. Sum of the three cubes is nothing but it's the same number, that is 3. Okay. So generally when we have three variables, we might need three equations, right, to get unique solutions, that is unique values of x, y and z. But in this case we may not be getting unique values. There can be more than one possibility for the set of x, y, z values, right? So our question will be to find all the x, y, z values. So we have to find out all the x, y, z pairs that will satisfy these two equations. So it will be an interesting approach because we will not have any straightforward method to solve this system of equations because we have three variables and only two equations. So we might have to do some numerical analysis to obtain the solutions, and I assure you that it will be a very interesting method. Okay, so I'm going to use one of the algebraic identities which is not very much known. Okay, you must have heard about x plus y plus z the whole square, right? So that is x plus y plus z the whole square. This is a well-known identity, isn't it? But do you know what is x plus y plus z the whole cube? Okay, so this is something that many of you might be seeing for the first time, but it's good, right, to learn something new, isn't it? So x plus y plus z the whole cube. So this is equal to x cube plus y cube plus z cube, and we still have some more terms, that is 3 times we have x plus y, and then we have y plus z, and then we have z plus x or x plus z. Okay, so this is the identity x plus y plus z the whole cube. This will be helping us to solve this problem. Why? Because you know that x plus y plus z is known, right? It is equal to 3, and x cube plus y cube plus z cube, this is also known, it is equal to 3, isn't it? So we can just directly substitute these values. So x plus y plus z is 3, so this is 3 cube, and this is equal to x cube plus y cube plus z cube. This part over here is also 3, so we have 3 plus the other part is not known, so we'll keep it as it is, x plus y, y plus z, and z plus x. Okay, yes. Now 3 cube is 27. This is equal to 3 plus 3 times. I would like to do some simplification in x plus y, y plus z and z plus x. I will go back to the original equation, that's the first equation. Now let us find out what is x plus y from here. So from this equation we can easily see that x plus y is nothing but 3 minus z, right? We just bring this z to the right side, so it will become 3 minus z, so we get x plus y. In the same way, what is y plus z? To get y plus z, we bring x to the right side, so it will become 3 minus x. And then what is z plus x? So z plus x will be nothing but 3 minus y. We will substitute these values in the place of x plus y, y plus z and z plus x. So let's do that here. So x plus y is nothing but 3 minus z, and then y plus z is 3 minus x, and this one is 3 minus y, right? So why did I do this? You will understand later on. Okay, now I'll bring this 3 to the left side, and I will write this variable terms on the left side. Okay, so I will write this here. So we have 3 times, and I would like to start from 3 minus x because of the order, right? X, y, z is, I mean, the correct order to follow. It looks good, isn't it? So 3 minus x, 3 minus y, and 3 minus z. So this will be equal to 27 minus 3, which is equal to 24. Right? And I would like to bring this 3, right? I would like to divide both sides by 3 so that we can get rid of this 3 from the left side. So divide by 3 here and 3 here, so that we have 3 minus x times 3 minus y times 3 minus z equal to 8, right? So this 3 and this 3 got cancelled out. So now let us analyze this equation. This is a very important equation. This will give us a lot of insight into getting x, y, z values. Here you can see we have 3 terms, right? 1, 2, 3. 3 numbers are multiplied and we are getting the result as 8. And I forgot to tell you one more thing, that here x, y, z should be integers. So we are interested in only integer solutions. So x, y, z they are integers. Okay, they should be integer solutions only. We are not interested in fractions or decimals, okay, because it's a little bit difficult to analyze. Anyway, you can try it out. Okay, I would like to get the integer values for this equation. So we have three integers, 1, 2, 3. When multiplied together, they give us the result as 8. Now you have to do some guess and check game. Guess the values. So let us start with 2 into 2 into 2, right? So 2 times 2 times 2 will give us 8, isn't it? So we can assume that this is 2, this is 2, and this is 2, right? Because when you multiply 2 into 2 into 2, you get 8 as a result. But the values obtained from this should satisfy the equations, that is x plus y plus z equal to 3. This is one equation. And then we have another equation, x cube plus y cube plus z cube equal to 3. So the x, y, z values should satisfy both of these equations. Only then we can consider them. So if you equate 3 minus x to 2, if you equate 3 minus x to 2, you get x value as 1, right? Because 3 minus 1 is 2. In the same way, if you equate 3 minus y to 2, you get the same value, y is equal to 1. And from 3 minus z equal to 2 also, you get the same value, z equal to 1. So we get one pair, x, y, z, all of them are equal to 1. So does this value satisfy these two equations? I think they do satisfy, right? Because you can see 1 plus 1 plus 1 is nothing but 3. And in the same way, 1 cube plus 1 cube plus 1 cube is also 3, isn't it? So we got one pair of solutions. Okay, I mean one set of solutions. So that is x, y, z. They are equal to what? 1 comma 1 comma 1. But there can be more solutions, right? So we cannot assume that, okay, these are the only solutions. Let us try to find out. Okay, let us work out with this equation itself and then try to find out more solutions. So I'll rewrite the equation here, 3 minus x times 3 minus y times 3 minus z equal to 8. Let us try with some more numbers. So we tried with 2 into 2 into 2, right? So let's see if some other numbers can work here. I will go with 8 times 1 times 1. Right? So 8 into 1 is nothing but 8, isn't it? So do we get some correct solutions from here? See, if you equate 3 minus x to 1, I mean, sorry, it's not 1, it's 8, right? So from here, we get the value of x as negative 5, right? Because 3 minus of minus 5 is 3 plus 5, so we get 8 as the answer. If you equate 3 minus y to 1, you get the value of y as 2, right? Because 3 minus 2 is 1. Similarly, 3 minus z is 1, applies that z is also equal to 2. We got some other solutions satisfying this equation, this green colored equation, but do they satisfy the original equations? So the first equation was x plus y plus z equal to 3, right? So if you add these three solutions, x, y, z, do we get 3? We don't get 3, right? Minus 5 plus 2, right? 2 plus 2 is 4 and minus 5 plus 4 is minus 1. We get negative 1. So these are not satisfying the original equation. So we have to reject them. Okay, these are not the correct solution. So we reject them. Okay, let me put a big cross mark over here so that you understand that we have rejected these solutions because they do not satisfy the equations. Then what should I do? 8, 1, 1 did not work. Maybe I can go for 8 minus 1 and minus 1, right? 8 into minus 1 is still 8 because negative 1 into negative 1 will be positive 1. Let us see if we get some solutions or not. 3 minus x equate to 8. As you know, from here we get x as negative 5. We have already solved this. If you equate 3 minus y to minus 1, from here y will be equal to minus 4 because 3, okay, sorry, it's not minus 4, it should be plus 4, right? Yes, because 3 minus 4 is minus 1. In the same way, 3 minus z, if you equate to minus 1, you get the value of z as 4 itself. Again, 3 minus 4 is minus 1. Do these solutions satisfy the original equations? So one equation is x plus y plus z is equal to 3. So if you add these three numbers, that is minus 5 plus 4 plus 4, do we get 3 as the answer? Yes, we do get, right? 4 plus 4 is 8, 8 minus 5 is 3. So we get 3 as the answer. But this solution should also satisfy the other equation as well, that the sum of the cubes, x cube plus y cube plus z cube should also be equal to 3. So what is x cube? X cube is minus 5 the whole cube plus y cube is 4 cube plus z cube is 4 cube. This is equal to 3. Or We have to verify if it is equal to 3. We cannot say that it's equal to 3. Let's verify. Minus 5 cube is minus 5 into minus 5 into minus 5. So if you cube 5, you get 125 as the answer. Since we have negative to the power of 3, we retain the negative value. Minus into minus into minus will result in minus sign itself. Plus 4 cube is 4 into 4 into 4. That is 4 times 4 is 16. 16 times 4 is 64. So we have plus 64 and here also 64. So we get minus 125 plus 128. Okay, so you can see that we are getting 3 as the answer here also, which means these 3 solutions also satisfy the 2 equations. So we can say that these are also the solutions. So we got one more pair, that is x, y, z. Earlier we got 1, 1, 1, right? So we got one more pair, that is minus 5, 4 and 4, right? But you can see that here x plus y plus z equal to 3 and x cube plus y cube plus z cube is equal to 3. These equations kind of look like symmetric equations, right? What do I mean? It means that we can switch around the values of x, y, z, isn't it? Okay, I can switch around the values of x, y, z and they will still satisfy because all are positive signs here, right? X plus y plus z and x cube plus y cube plus z cube. So I can interchange the values of x and y and z and it will still satisfy, isn't it? That is, I would like to explain this in detail. Okay, let's go back to the green colored equation that we had written, right? 3 minus x times 3 minus y times 3 minus z equal to 8. So earlier we took the values as 8 minus 1 minus 1. But what if I interchange these values? For example, let us say I will put this one as minus 1, this one as minus 1 and this one as 8. We will get the same solutions, minus 5, 4, 4, but in the switched order. That is, if you solve them, you get the values of x, y, z as, see, for you can go back and check this. For minus 1, we get 4, 4, right? If you equate it to 8, we get minus 5. So that's what happens here also. Okay, so for minus 1, we get 4 and 4 as the solution, and the last one will give us minus 5. Okay, so this still will be the solutions. And in the same way, let us say instead of minus 1 here, if I put this one as 8, okay, let me make it 8, and if I make this as minus 1, right? So this will still give us the solutions x, y, z in the switched order. That is, first one will be 4, second one will be minus 5, and third one will be 4. So these will also satisfy the original equation. So let me write the equations here. That is x plus y plus z equal to 3 and x cube plus y cube plus z cube equal to 3. Okay, so let us list all the solutions that we have obtained. So we have obtained earlier one solution, right? That is minus 5 in the beginning, minus 5 comma 4 comma 4, and the first solution, the very first solution, that is 1 1 1, right? Okay, so these are the 4 solutions that we have obtained, and let me assure you that these are the only 4 possible solutions. Okay, so you might ask, there can be other solutions, right? Yes, there can be, but I am saying there are not, because if you take this equation 3 minus x into 3 minus y into 3 minus z equal to 8, we saw the possibility of 2 into 2 into 2 and 8 into minus 1 into minus 1, right? We can also go for 2 times 4 times 1, okay? Or you can switch around the signs, minus 2 times minus 4 times 1. You can try with them and you will obtain the xyz values, but they will not satisfy these equations. They should satisfy both the equations. They will not satisfy them. I will leave this as an exercise for you because the video will become very lengthy if I go on trying with all the numbers. But my final conclusion is that these 4 are the only possible pairs of solutions, the set of solutions for x, y and z that will satisfy these 2 equations. I hope you enjoyed this video. For more such interesting videos, kindly subscribe to my channel. I will see you all in the next video.